Hey guys, Wages World here, July 26, 2020, coming at you with a video. I'm just going to jump into it. I'm going to try it like this from now on, guys. I know I say that a lot, but I'm going to try it without giving a rundown of what's in the video. And just let me know how you guys like it like that. I know you guys probably don't want to hear my voice any longer than you have to. Tony here, she dropped a lot of comments. She's been around for a while and everything's been great. I mean, I appreciate you being here, Tony. Says, it's horrific. She's talking about her succulents are getting burnt around the edges. She's talking about reference to the last video. That's where this comment was left, obviously. But I work part-time in lawn care, guys, and everybody comes up to me asking and saying the same thing. I don't have to initiate the conversation at all. So I know that it's not just in our head. Other people are seeing it. Something's changed. You know? Look, 11 replies. That's awesome. Adamant. He basically saying the same kinds of things. He left his shirt out one day, I guess, for just a few hours, and it bleached it. That's kind of going down the same road here. Listen, you know, I know we could talk about dye issues there and shirt and material, but he's basically saying he's done this before, and it did it a lot faster than what it used to. So I guess at this point, guys, you know, all of us can probably agree that something has changed. Where the conversation gets started up is what's changed, and that's really what we got to figure out, right? There's a lot of different theories. We can talk about HH or HAAR, not going to say the last letter, but it has to do with weather and not naturally, okay? That, we can talk about the sun simulation, that kind of a thing. We can talk about atmosphere in general, the sun itself, all these things, right? And, you know, I'm of the mindset it's probably a little bit of all of it. I think it's all tied together. That's just how I look at it, guys. So yeah, that is what it is. Guys, we had like 43 replies in one of the comments in the previous video. I love that, guys. That's been my goal since day one. I want to get conversations started respectfully, okay? And because that's how we're going to find answers, and that's how we're going to know that we're not alone in all this. So hopefully anybody new here can kind of grasp hold of that. And, you know, guys, thanks for being here. Because, man, that's what keeps me motivated, stuff like that. You know, I've actually facilitated a place where people could come and talk. And not really feel, you know, like they're going to be attacked. If they are attacked, I can get rid of it. You guys know that. So just know that. So anybody new here, feel free to ask any question you want. And if I don't answer it, I've said this a bunch, somebody else will. At least give what they think the answer is, and they'll try to help. It's great. I can't even believe it's turned into this. It's awesome. I'm getting between 500 and 1,000 comments in each video. A channel of my size getting those kinds of comments is unheard of. It typically doesn't happen like that, guys. So I appreciate it, guys. I really do. It makes me feel great that at least I think I've helped a little bit, I guess. But yeah, so we're going to move on. Okay, guys, I got you over here to the YouTube page. Some of you might recognize the name here. And forgive me if I butcher this. Verte Arbustos Schumann Resonance Harmonics. It's a long name. But yeah, sorry if I butchered that up, man. Guys, he left a comment talking about, remember we were talking about the Schumann? And it had the coded line thing, and we've been trying to figure out what that is or what could be causing it. At least the possibilities. And he, you know, took the time and wrote up a big comment there a couple different times trying to help everybody. I did not know he had a channel. He's got a channel. He's only got 45 subs. But let's change that, guys. Let's change that up for him. I mean, come on. And what is this channel? What's this channel about? The Schumann Resonance. That's all it's about. And pole shift stuff. He's talking about magnetics. And he's got some playlists here. Okay? But listen. I want to watch this video right here. He just dropped it like a day or so ago. A day, right there. And if you guys want to know what the Schumann graph is trying to show you, like what the graph is representing, so we can understand it better, you need to go watch this. And it's a part one, so I'm sure there's going to be many parts of it. He'll break down what's going on here in this graph and what it's actually trying to show you. The data is trying to show you. So go give him a sub, guys, please. Put Wages World sent you or something like that in a comment for him. Let's get him up over 1,000, because I know, like I said before, I don't monetize, so I don't care about that at all. But you have to have 1,000 to monetize your channel. And, you know, I think people that do that for their job is awesome, even for extra cash, you know. But it's just not what I do it for. That's just me, okay? But other people deserve that. So if we can get them to that level, you know, especially when they're helping us like this, you know, try to do it. Just get, what's it take to drop a sub over there? And if you don't like the information, don't like how it's being presented, you can unsub. But give him a chance. I mean, it seems like he deserves it, guys. He took the time to do that in the comment section and never once asked to get people over to his channel. I've never talked to him outside of the comments. That's it. So just know that, man. I mean, go help him out, guys. So we're going to go look at the current Schumann. Plus, guys, listen. I had to be taught this just like everybody else did. And I'm still learning so much. I'm learning from him right now. And Mike and Cindy over Evolutionary Energy Arts, they helped me out with the Schumann a bunch. Okay? Higher Realm Holistic. She's down in Florida. She's a nurse. She has good stuff on this. Fifth World. She's got good stuff on the Schumann resonance. Guys, go check these channels out. I'll leave some links and stuff. Okay? But if you want to know more about this, you know, get all the information. Even if you don't like the people. Okay? You think I don't watch channels that I don't like the person that's actually doing it? Of course I do. I think we all do. I'm just not going to sit here and lie to you and tell you I don't. Because I do. I think even if a person is mean or whatever, however you want to put it out there like that, or attacks me or whatever else, they can still have correct information. I'm trying to get all the info I can to make the best decision on what I believe. And I would hope that everybody here is doing the same thing. And, you know, we just do it different here. We're respectful. So that's what we do, right? But doesn't mean we can't still get good information in some of those places. We just got to be, you know, vigilant about it and make sure it's correct and, you know, just look at it. That's all. So go check everybody out, guys. I mean, I'm not saying that I like all those people I just mentioned, by the way. But listen, there's others out there that I watch that got good info, but they just are mean, I guess, if you want to put it that way. So we're going to look at the current Schumann. Alright, guys, I got you over at Mr. MBB3's page. This is where I go to get to the Schumann tool. And notice what I said there. I said Schumann tool. It's what it is. It's a tool for us to look at. So this is just how we navigate to get there. There's other tools out there you can go look at, but this is just the one we use. Now, if you go down here, down on the bottom left, you see where the green tab, it says new UV readings. If you guys want to know what the UV stuff is, go click on that. He helps you out here. It's awesome. But we're going to go look at the Schumann from the bottom right hand here. He's got the ISS live feed on there. I mean, there's a lot of good links here. So we click on the Schumann here, and this is what we get. So, what are we seeing? Well, you know, we got the spike over here, like I was talking about the other day. Same spike. What was strange about it is it actually tapered from the bottom up and the top down. So that was new to me to see. At least I hadn't noticed it before. But I also mentioned in my last video that we've seen another one starting. And but what was interesting about this is it almost took the same exact shape as this other one. So it was probably the same source. It was just intermittent there. Okay? Pulsing, kind of a wave action. Didn't look to be as intense either, but it was still there. So they put this in the ISS, guys. They put this underground. If they don't, people go crazy. They used to call it space sickness. And what this used to look like, 7.83, that 783 line right there, always stays. Okay? But now we're seeing this other one staying. This one here is starting to do the same. Now you can see the next level up is too, but we're still getting some breaks in it. This is what it used to look like, except it was all the way down till you got to the 783. So this is just proof that our frequency has risen, and it's staying there. Is it good, bad? Both, I guess, if you want to look at it like that. Again, mental health issues go crazy when it spikes. People go to jail. People get, you know, suicide rates go up. So many studies, guys. I'm talking thousands. Okay? You can research it. It's easy to research. Cardiac places, like I said, Higher Realm Holistics. She works in surgery, so, you know, she sees a different perspective there. And the cardiac units are now using that and kind of monitoring it during their surgeries and stuff. So, and this also touches every other piece of research anybody does. This touches everything. Okay, this affects everything. And almost everything affects this. Imagine that. You know what I mean? Alright guys, I got you over at SWPC, Space Weather Prediction Center, NOAA. And what we're looking at here is the solar X-ray flux. This is starting to rise, the base level is. And why is it? Because we have a sunspot, 2767. Okay, that's the number they gave it. It actually has a number, it's official, right? But we also have another active area getting ready to rotate Earth facing. So what you're going to see is, you're going to see this base rise up a little bit more. And as long as those sunspots are facing us, or active areas, sorry about that, guys, that will definitely stay up. So what's that mean? Well, what it means is, if we get a flare, it's already at a higher level, so it could affect us more. Okay? When you see spikes on this, those are solar flares, pretty much. All right. So yeah, so we monitor that, and that is not a whole lot more we can do with it, but that's what's going on. We had the two sunspots, or the one sunspot, and the active area. So we got to keep an eye on those, because CMEs and solar flares, they come from those more often. The chances of having those kinds of things are greater around sunspots, just so to give a little bit of perspective there. So we got the geomagnetic activity here. Now this is what we look at when we're looking at magnetic storms, geomagnetic storms. Okay, CMEs, solar flares will show up on this. Solar wind streams that are high show up on this. Okay, so what we had a solar wind stream, and there was a CME in there too, all at the same time. And we took a hit from it, but we didn't get into storm level. Okay, we see how we went up to 4 right there. We did back here too, a couple different times. It's kind of up and down a couple times, but I think that's because of the way that it hit us. So, and I explained that yesterday, but we never got to G1. So what does this mean? What did it do? Well, it brought down the auroras down closer to the equator, and it added overall energy to us. So, you know, when something is absorbing energy, it usually gets stored. It has to be released at some level, at some time. You know, we call them capacitors here when we're using them for machines. They store energy, and when they get full, they release it. But we can actually make capacitors release when we want them to. But they're essentially just basically a big battery, I guess, if you want to get down to basics. But I used to work on big printing machines at a factory, and that's what we did that for 20 years. But we use capacitors. You know, they're usually right around, they're in the transformers and stuff. So I'm familiar with all that. But that's kind of what this does. You know, when we get this kind of energy shot at us, you know, we got to watch for earthquakes and lots of other different things, guys. But here's our sun right now. Okay, here's that sunspot, 2767. Okay, and then here is that other area kind of rotating in, right? We'll take a look at it a little bit closer. It looks, if it holds together and it stays like that, it's going to be bigger than this one down here. Now, whether or not it's an official sunspot, or if it sticks around long enough to get a number, I don't know. That's to be said, or to be seen. So we got the, oops, that was ridiculous. Anyway, we got a straight line there, and the Earth kind of sits here, just to the south of the equator of the sun. Now you can see the coronal holes underneath it, right? So when those things rotate in that direction, the sun's rotating this way, and when those rotate in front of us, it's called the Earth strike zone. All right. So when stuff is there, we're more apt to take energy from it, and that's most certainly the case. And that's what happened, 3 or 4 days ago, almost 5. We had coronal holes there for a couple days that were right in front of us. So that's how long it took for that solar wind stream to get here. All right. So what are we looking at coming up? Well, we got this coronal hole right in front of that active area. But you're probably saying, well, it's kind of far north, isn't it? Well, let me explain. Again, here's the equator, here's the Earth. Well, when this thing starts getting closer and closer here, right, the chances of us connecting to it become greater, and most likely we will connect to it at some level, right? So we got coronal holes at the North Pole and the South Pole of the sun that stay there all the time. But we also got these patchy ones. So we're going to have intermittent increases in solar wind for the next week or so. And if this one at the top here gets any bigger, grows or what have you, we could see a decent sized solar wind stream increase from that. So like I said, let me explain. Sun, Earth, we're connected by interplanetary magnetic field lines. If we connect from here to here, which does happen, that's what I'm trying to say, guys. It's magnetically we're connected. The interplanetary magnetic field lines is what connects us to the sun. And what is solar wind? Solar wind is charged particles traveling to us from the sun. Okay, how do they travel? Well, they take this road right here. It's called the interplanetary magnetic field line. The dense ones are like that, closer to the middle. The lighter one, or the less dense, are out here like this. Okay, so I said this a bunch, but usually when density goes up, the wind speed goes down. And when the wind speed goes up, the density goes down. Okay, so they do opposite. Now they do sometimes go up at the same time and come down at the same time. Usually around some sort of an event, like a coronal hole or a CME, solar flares, that kind of stuff, right? But don't be confused to think that this can't connect to us, because it can, and it will probably. So we'll probably see increased conditions. But even though it does have a better chance to connect to us pretty solidly, if it is closer to us down here. If we had this same hole sitting right here and it went there, we most definitely would be getting some weather from that. So just know that that's what's going on there. Okay, guys, CME tracker. Here's that other CME. We had another CME, but it blew off to the right of us. Okay, it's not going to hit us. It's not going to affect us hardly at all, if any. You can see it right here. That's Earth. Here's the CME. Okay. Now you're probably wondering, where's the other CME that just hit us yesterday? Well, the way I understand this graph, and Scott taught me this very early on, because I used to think the same thing. This thing doesn't update unless it sees the CME. It isn't continuously updating, is what I'm saying. So once it detected this CME, it pretty much got rid of the other one. The other data's not there. It's showing you from the point of this CME on forward. Okay? That's why you're not seeing that other one. Just so everybody understands that. So this thing won't update unless it sees the CME. The other Enlil model I show you, it looks very similar to this. It updates constantly. That's why I don't trust it 5 days out, because it continuously takes new data and changes the model. It's like local on your 8s, which changes hour to hour. You know what I mean? So just keep in mind that's the difference here. So that's what you're seeing. But this one here probably won't affect us hardly at all. But it did do something, and let me show you. This is what it did. Scott sent this to me over today. Guys, this just simply speaks for itself. He's on top of this. And this is what he's doing. And this, my gosh. Like I said before, we let the observation speak for itself. We don't need to say anything. It goes for anything, really. We can give our opinion and understanding on what we think stuff is. But at the end of the day, you're going to make up your own mind, right? That's what we want. But we want to show you the observations that we're making, too, to help, that. To see if maybe we can at least help people understand what we're seeing. So, again, that's when that CME happened, there you go. Yeah. He's on top of this. So, you know, he's probably going to do a video on this, I'm assuming. So, you know, I appreciate this. He sent this over to me. And, yeah, that's the CME blowing off to the right. And that's what it lit up. So, there you have it. There's a lot of stuff going on that we're trying to figure out too, guys. You know, yeah, there's a lot of stuff going on out there right now that basically we don't have very good explanation for some of it. And we never do until we do have an explanation, you know what I mean? But yeah, another great job here just by catching that. I mean, wow. So when that solar stream and stuff hit us, this is what our magnetosphere looked like. Okay? Now don't think this is something we shouldn't be seeing, because we should. When we get hit with stuff like that, this is what we should expect to see. Even more crazy than this. But this here was something, a couple signatures I really haven't seen before. So let me explain. You see how this has kind of got its own little signatures? That was kind of strange. We don't typically see it, especially rounded and soft on the edges like that. And now here in the front, we do see this quite often though. You see how the energy, our bow shock is up here? But that's the solar wind interacting with our magnetic field. That's the point of where it interacts. It's called our bow shock. You see how down here it doesn't really have that much of a pressure being put on it? So whatever we're getting hit with right there is actually more so up here. Almost directional. I don't want to call it directional because I'm not sure if it is at this point. But you can see if you zoom in here how it's almost got a gap right there. And that's pretty consistent with what we see, guys. Stuff comes into our poles easier by those lines I was just talking about. Okay? But, you know, you can see a weak spot back here. I'm calling it a weak spot. It's just a magnetic spot there that's a little bit different than what's around it. Okay? But, yeah. Also, this model is two-dimensional. Trying to show you something that's three-dimensional. Our magnetic field looks almost like a donut cut in half, or 3/4, and we're in the middle of it. Okay? That's pretty much what our magnetic field looks like. So we got to keep in mind this stuff isn't just in a straight line like a video game. Okay? It actually will hit us and go up over top. It'll hit us and go down. It'll not really hit us. I mean, it's traveling those lines of connectivity. It can go up to the right, which would look just like that. Okay? Or go to the left. Guess what the left would look like? Just like that. Because it's three-dimensional. Right? So that's what I want people to understand on this one. It's hard to wrap your brain around that. I get it. I really do. But that is what you're seeing. Here's the solar wind part of the magnetosphere. It shows you the direction it's traveling. But what I want you guys to look at is the wind speed itself. Remember, between 3 to 500 is normal. What we can consider normal or a little elevated or a little bit low. But look at that. 1,745. That's kilometers per second. That's probably roughly around 3.5 million miles per hour. I don't know exactly. We could convert it. You guys can go to the conversion charts if you want. There's a bunch of them free out there on the internet. Not hard to do. Just type in kilometers per second, enter that number, and convert it to miles per hour. You click the button, and it tells you how much that is. It's pretty simple. But, yeah, that's fast, guys. Okay? Now, we've seen it faster. I've seen a number of 25, maybe even close to 3,000 there. Now, I often wonder if that's correct, because that is awful fast. You wonder how accurate that is. But, you know, and it was just for this one capture. It's not like the solar wind speed we see over Space Weather Prediction or on the ACE data. It's a little different. So, whatever. You know what I mean? I'm just showing you different areas here. So, this is LASCO C2, guys. Seeds hasn't updated for about 3 days on LASCO C2 or Stereo A. Those are two different satellites, okay? LASCO C2 is on the SOHO satellite, and it's from our view. There's Earth, there's the satellite, look in this direction. Now, yes, Earth is way further back. I just want to show you guys that. Stereo A would be over here. Okay? So we got to keep that in mind. Perspective is important with what I'm getting ready to talk about. So we see the CME getting ready, it's starting to blow off right here, right? Because we can still go get the data over at ISWA, but SEED shows it in that black and white view. That's why we go there a lot. But we, if it's not showing up there, we'll go to ISWA and look at it because it's here. But we just don't get the black and white view. But look what shows up. What is that? You know what I mean? You can clearly see it has some sort of sparkling, trailing tail there, or even in the front here. Okay? So, remember, that's the front view from our view, right? Let's go to stereo A. Earth is over here. Satellites here. What's that? Now remember, Earth is way far back. Okay? It would be so far off the screen, it's ridiculous. But I just wanted to show you our perspective as far as what we're looking at. We're looking from this particular satellite is looking from the side of the sun, looking at the side of the sun, the left side, if you want to put it in those terms. Okay? And look what shows up. Okay? So you look at that from that perspective, and that's there. And then you go back here and you look at it from this perspective. It's the same height as far as in correlation to where the sun's at. It would be in the same viewing spectrum. So that's the same object, guys, whatever that is. I thought it was just a camera anomaly or whatever, but when I went over here and seen that at the same time, that tells me that something was there. And it would be probably closer to the sun than what it is to us. Because stereo A has only got so much of a view. Right? So, you know, Earth's not even in this field of view. This is closer to the sun than what it is to us. So here it is with the brightness taken down on it a little bit. All right. Here it is on stereo A, side view. And you can tell it's pretty much a similar shape. Now I know that there is very, very pixelated. Nothing I can do about that, guys. That's just the camera they gave us. Right? So, yeah. So, I sent him over to Scott. He's like, man, that's interesting. So he did this. He just basically inverted it. Probably brightened it or lowered the brightness or something on it just to show what was there. Okay? I mean, wow. Wow, wow, wow. And again, you can tell that has some sort of a trailing sparkle behind it. Now, I can't tell you what direction it's moving or whatever. I don't know what's going on here. I don't know what that is. I need people to tell me what their opinion is on this. I mean, look at that. So if we're looking at this, you know, I remember seeing something similar shapes to this, but if it's out that far, this object is huge. So I wouldn't even know I don't even want to say what it looks like. You guys know what I think it looks like. So I'm not even going to say it. So yeah, it starts with a U and ends with an O. What's in the middle? Give me an F. Yay! Anyway, have a little fun there. But you got straight line, and it's probably curved right here, just like this is over here. And again, I thought maybe it was a camera anomaly, but when I started seeing it on both satellites at the same time, it kind of debunks that. So I don't know what this is, guys. I'd like to see what you guys think it is. Drop some comments down there. Let me hear it. So with that, guys, I'm going to end the video. Guys, please go over and check out the Schumann Resonance channel. I said I don't want to butcher the name again. Arburstos. I think it's Verte Alberstos, Schumann Resonance, something. I can't remember exactly what the name is. But I'll leave a link. I'm sorry if I butchered that name, by the way, buddy. But, yeah. So go show him some love over there. Give him a sub. Okay? Do it for me. God bless. Yeshua saves. And you can drink this Kool-Aid.